Okay, so I have shared my whiteboard. Okay, today we'll talk about vectors. Okay, before talking about the contents of vectors, let's just see what exactly a vector looks like. Okay, so when we talk about vectors, we can define it this way. Let's say AB is a vector, we make an arrow on top, and let's say this is the vector AB. Okay, now a vector at your level is basically a line with direction. Okay, when we talk about line segments, this is a line segment, this is a line segment, this is a line segment, right? But when we talk about vectors, I need to add direction to it, and now it is a vector. Okay, so this is how we talk about vectors. Now you'll see in your case, like in your at your level, we'll be talking about different vectors. We'll see how to find the magnitude, how to know if two vectors are equal or not, how to find the negative vectors, how to see if two vectors are parallel or not, and stuff like that. Okay, so let's talk about the mathematical representation of any vector. Okay, so we can define any vector using a column vector this way. We write down the x component and we write down the y component. For example, let's say I have 2 and 1. Okay, now 1 is the y component and 2 is the x component. So I can show that vector on the graph to you guys. So it is 2 and it's 1. This is the point, right? And the other point would be the origin. Now I'll make a line connecting these 2 points and I'll make the arrow because I'm going from the origin to this point. That is why the arrow is in that direction. So this is the vector A, B, right? This is the column vector and this is the interpretation. This is how we plot any vector, right? Any confusions with the understanding about vectors, with the basic understanding? Yes, I'm not able to hear anyone. Yeah, okay. Can you, okay. All right, it's clear. Turhan, did you understand this? Okay, all right, okay. Now, as I told you earlier as well, when we talk about vectors, yes, this discussion was important, but we'll be talking about the magnitude, we'll be talking about the direction. Okay, this is what any vector has. So first thing is finding the magnitude of any vector. Let's say this is your vector. You've been asked to find the magnitude. So you write it down this way, AB mod. Okay, this is how you write it down with these two straight lines. This is the notation for the magnitude of any vector. It would be under the root, then square of the horizontal component plus square of the vertical component. That is it. Okay. If I talk about a quick example, so let's talk about 3 examples. Okay. Let's say for the first one, you have PQ and the column vector is 5 minus 8. For the other one, you have BC and the column vector is 2, 4. And the third one is AD and the column vector is minus 5 and 2. Okay. And the question is about the magnitude. So we know how to find the magnitude. This is how we write it down. PQ with 2 straight lines. We do under the root square of the first number plus square of the second number. So this would be under the root 25 plus 64. And what is going to be the answer? Can anyone tell me? It would be under the root 89. Okay. If we talk about the next example, the magnitude of BC, which is represented this way, would be under the root 2 squared plus 4 squared. It would be under the root 4 plus 16. And once you simplify this, you will get 2 under root 5. And yes, can you guys tell me the magnitude of AD, this vector? Yes, Turhan and Saneem? Very good, excellent. Okay. And what about you, Turhan? What would be the magnitude of the vector AD? No, it would be under the root minus 5 squared plus 2 squared. That would be under the root 25 plus 4. And it would be under root 29. Okay. It is 29. It's not 49. All right. Okay. Now, when we take under the root, we get the answer with both positive and negative values, but we know that magnitude should be positive only, right? Magnitude is just the size. It is the length of the line, okay? So this is how we do it. All right. It's good. Let's talk about the next concept, that is about equal vectors. Okay. Now, every vector has two properties, okay? So far, we have discussed two properties. The first one is the direction, and the second one is the magnitude. If two vectors are said to be equal, that would mean that their direction and their magnitude, both these things would be same. For this, let's talk about two examples. For example A, we have AB, that is 5 minus 8. This is example 1. And the other vector is PQ, and that is 5 minus 8. And for the second example, it is AB equals 3 minus 4. And then we have PQ, that is equal minus 3, 4. Okay. Now this question is for you guys. First, you need to check out the first pair of vectors, A, B, and PQ. Is the direction and magnitude same for both of them? Okay. Now for the direction, what do you need to see? You can see that since these vectors are exactly identical, okay, they are identical. So in this case, obviously, the magnitude plus the direction, they are going to be the same. This is obvious. It has minus 8, it has minus 8. Let me quickly plot AB just so we get comfortable with the interpretation as well. Okay. How do we interpret? How do we plot any vector? This is the y-axis. This is the x-axis. This is the horizontal one. This is the vertical one. Okay. So it is 5 and then it is minus 8. So it would be here. And now I need to make a line connecting the origin and this point, and it would be in the downward direction. Okay, this is origin 0, 0. All right. Okay. And this point has coordinates 5 minus 8. Now, this is how we interpret any vector. I know that since both these vectors are identical, so in this case, it's very obvious that their magnitude and their direction would be same. Okay. Okay, this was good. Let's talk about the second example. Okay, now I want you guys to find the magnitude of AB and find the magnitude of PQ. Yes. And I'm waiting. Yes, what would be the magnitude of AB and PQ? Yes, please tell me the magnitude of AB and PQ. I'm waiting for your response. Okay, let's find it together. It is under the root 3 squared plus 4 squared. It would be under the root 9 plus, all right, it is minus 4 squared, but that would not matter. The square of any negative number would still give you a positive answer. And this would be 25. And for PQ, the answer would be under the root minus 3 square plus 4 square. That would also give you 25. Okay. The only difference in these two vectors was of the minus sign. One had minus with 4, the other one had minus with 3. So the magnitude is not going to change. The magnitude is same. But what about the direction? The directions would be different. Okay. Let's plot that and see. Okay. So we know that the magnitude turned out to be same. I'll write that down. So it is 25 units. And this one is also 25 units. This is 3. This is minus 4. Here it is. And let me make the line. This is the line. So it is acting in the downwards direction. This is A and this is B. All right. Let's make the PQ1 and see how is the direction different. So the x coordinate is -3 and the y coordinate is 4. This is the point. So it would be going in this direction. So this would be the vector, right? Their directions are different. So that is why both these vectors are not equal. So for equal vectors, the direction and the magnitude, both of them should be same. Any confusions in this? Anything that you have not understood?
No.
Okay, Salim, what about you? Okay. All right, very good. Okay, this was for equal vectors. Now let's talk about negative vectors. Now, when we say negative vectors, we have opposite direction and the magnitude is same. Okay. And what is this? All right. Now, when we say that we have two negative vectors, their magnitude is same, but their direction is opposite. For example, let's talk about example number 1. Okay. So we have AB. The column vector for AB is -3 and 2. And the column vector for PQ is 3 and -2. Okay. By now, you guys should be comfortable. You guys should know this, that if the numbers are same, the magnitude would be same. Although the directions are opposite, the negative side is coming with different numbers in both these vectors. But since the numbers are same, the magnitudes would be same. Okay. So we know that the magnitude would be same, and the magnitude would be, let's find the magnitude of one vector. It would be AB mod, that is under the root, the square of this number. I'm just writing down 3 square plus 2 square. It would be under the root 9 plus 4. So that would be under the root 30. And this would also be under the root 13. Okay. But the direction is opposite. Okay. So this time around, I will make the graph and then in general, you'll understand this. So let's try making them on the same axis. So we have 3, we have -2, then we have -3, and then we have -2. Okay. The first point is AB, -3 and 2. This is 2 and this is -3. Okay. This is 2 and then this is 3. Okay. -3 and 2. This is the point. Let's make the vector. So it would be pointing in this direction. Okay. All right. And then the other point is PQ. It's 3 -2. It is somewhere here and it is pointing in this direction. Now everything is same. These lines are also same, right? Like the slanting thing and everything, that thing is also same. Like if I make them together, you'll see that these lines would be parallel. These lines would be parallel. But the only thing is that their directions are different. Okay. So just know that negative vector, if you are asked to comment about if two vectors are equal or not, they're equal when their direction and magnitude is same, and they are negative when their magnitude is same, but their direction is opposite. Okay. Opposite means that they are parallel, but the directions are opposite, right? Any confusions in this? Okay. So
No.
very good. Okay. So let's talk about some more examples quickly. I would want you guys to help me out for those. Let's say I ask you to help me write down the negative vector for this one. If you have -2 and 10, what would be the negative vector? Yes. If -2, 10 is the column vector for a vector, the negative vector would be the same. 2 and 10, the signs would be opposite, right? This is how we define any negative vector. If I talk about another example, let's say we have 5 and 0. Okay. So in this case, what would be your negative vector? It would be -5 and 0. And why is it so? Let's see that. Let me plot this 5, 0 quickly. So it is 5 on x and 0 there. Okay. So this would be the vector. And the opposite would be in this direction, right? So for this direction, we are obviously going to have -5 and 0. Is this okay? Do you guys understand this? How to find the negative vector? The numbers are going to come as it is. The only thing which you need to understand is the change in signs. Okay. So let's talk about the last example. And once we are done with these three, you would understand every case. -3 and -4. The negative vector for this one would be a vector with same numbers and signs would be different. So we did not add any sign. Okay. So, okay. What is the idea? The idea is just multiply a negative sign. That is it. Okay. Now I'll do all these examples again and you'll see how to do them. So Rania, at the moment we're talking about vectors, we are seeing how to find a negative vector. A negative vector has opposite direction but same magnitude. Okay. So same magnitude means that the numbers would be same, the signs would be different. So I will write down the vectors as it is with a negative sign. Now I'll multiply this minus with -2 and with 10. So this would give me 2 and -10. I'll write down this minus sign, -5 and -0. -0 is nothing. So it would be -5, 0. I'll add minus here and that would give me 3, 4. Okay. So always remember, for finding out negative vectors, just add a negative sign and then just multiply it with all the terms in the vector. Yes. Any confusions in this? Anything that you have not understood? Okay. And what about you, Turhan?
Yes.
Is this okay?
Yeah, it's okay.
Okay. All right. Very good. Now let's talk about a question here. So we'll see how to use the magnitude formula for finding one of the components of the vector. Okay. So let me write down the question first. And then once done with these, we'll talk about the past paper questions from vectors. Okay. So it says AB is a vector and the column vector is 6q. You have been told that the magnitude of this vector is 10. Find q. Okay. This is the question. All right. Now, what do we have? We have a vector. The vertical component is missing. All we know is that the magnitude is 10. We need to find q. So we know that magnitude of any vector is coming by the formula under the root x squared by y squared. This one is the x term. This one is the y term. So in this case, it would be under the root 6 squared plus q squared. I'll write down q squared directly and the magnitude is 10. Now this is my equation. I only have one equation. I have one variable. I can easily solve it. I can make q the subject and that would help me find the value of q. So step one would be getting rid of the under root. So I'll square both sides. This and this would be cancelled. This would give me 100 equals 6 squared is 36 plus q squared and 100 minus 36 equals q squared. And finally, what would be the answer? It is 64 equals q squared. So q is going to be plus minus 8. This would be the value. Very good, Saneem. Excellent. Okay. Yes. Any confusions in this question, all the students? Zain, Rania, Saneem, Turhan. Any doubts?
Yeah, that's fine. I know.
Okay. All right. Perfect. Very good. Okay. This was the next example. All right. Now let's talk about a past paper question. So I'll write it down. All right. Now please pay attention, all the new students as well. It's okay if you guys have joined late. We'll do this example and then things would be clear. Okay. So it says ABCD is a parallelogram. It is given that AB is 7, 0, and BC is -3, 4. All right. Let me make the diagram now. So it is DC and it is AB. Okay. We all are familiar with parallelograms. Okay. Then that depends. Okay. That depends if it's P1 or P2. In P1, obviously, it would be for less marks, but in P2, you'll see when we'll do past paper questions, it could be a 4 to 6 mark question, right? But that actually depends. We'll talk about past papers in some time, so you'll get the answer. Don't worry about it. Okay. So, yeah, this is the idea. Okay. First part of this question says, find the value of this. So we need to find the magnitude of AB. All right, so that is easy. How do we find the magnitude of AB? We have been doing that under the root x squared plus y squared. It would be under the root 7 squared plus 0 squared, and it would be 7. So 7 is the magnitude of AB. All right. The next part is important one, and that is why I wanted to do this question with you guys. It says, now please pay attention. It says, express each of the following as a column vector. All right, so it is DC Okay. Now you need to find DC and you need to find DA. And this is what we have. Okay, all right, that is good. Okay, let's see how to find DC. This is DC. We know that DC is parallel to AB. This is a parallelogram, okay? So what do we know? We know that the size of these two sides and the direction, they are going to be same, right? So the direction is same, that is given, the size is same. So when magnitude and direction in case of vectors is same, what do we know? We know that the vector would be an equal vector, right? So this is going to be same as the vector AB, and the answer is going to be 7, 0. All right. This example was good. All right, okay. I've removed that student. Okay. So this is what it is. It's DA. All right. Now we need to find DA. How do we find DA? Now DA is parallel to BC. Okay. Sorry, AD is parallel to BC, right? AD is parallel to BC and their directions are same. So in that case, what are we supposed to do? We are going to write it down this way. It is equal to minus AD. Okay. We know that DA is equal to minus AD. And what is AD? AD is same as BC. So I'll just write down -3, 4. It would be minus, and this is 3 minus 4, right? Do you guys get this?
Yes, ma'am.
Yes, Turhan and Rania,
Yes,
any confusions?
No,
Yes,
it's
and
clear.
yeah, Zen, did you understand this example?
Yes, ma'am.
Okay, perfect. All right, so this is how we do this. Okay, let's talk about one last thing for today. That is the concept about parallel vectors, and then that is it. Okay, this is the next thing that I wanted to talk about. Right. So just remember that in case of parallel vectors, you would have same ratio of x and y. For example, if we have two pairs of vectors, let's say you have AB it is 6, 6. And then you have PQ, and it is 3, 3. Okay. So you need to check if these two vectors are parallel or not. For that, what do? We find the ratio. We'll find the ratio, and that should be same. Okay. So this is x1, this is y1, this is x2, this is y2. Okay. So the ratio for x's should be same as for the y's. x1 by x2 should be same as y1 by y2. So it would be 6 by 3. And again, it is 6 by 3. Since they are same, it would be 2 equals 2, right? Since the ratio is same, that means these vectors are parallel. Okay. Now, if you guys know gradients as well, in that case, we know two lines are parallel when their gradients are same. Okay. This concept is basically coming from the same idea. AB and PQ would be making two lines. Okay. Then for both of them, we don't write that, like we write these things down for matrices. Okay. For determinant as well, this is how we write it down, or we write it down this way as well, determinant of A. And for magnitude, we write it down with straight lines and this way. Okay. We don't use the square brackets. We just write down the straight lines. Okay. All right. So this is how we talk about parallel vectors. Okay. Yeah, symbols are same. Symbols are same. Okay. Let's talk about one last example for this case. -3, 4, and 6, -8. Okay. Now again, we need to see if A, B, and PQ are parallel or not. So we will do x1 by x2 equals y1 by y2. We need to check that actually. So this is x1, this is x2. So it is -3 by 6, and it is -1 by 2. Let's see, in case of y's, this is y1 and this is y2. So it would be 4 by -8, and it would be -1 by 2, right? Since they are same, this means that AB and PQ are parallel vectors. Yes. Any confusions in this? Any doubts in vectors? Anything that you have not understood? Yes, Saneem, Turhan, Rania, and Zain. Any doubts?
No.
Okay, Rania. All right, perfect. Turhan, did you understand this?
Yeah, no, yeah, I understand. No problem.
Okay, perfect. So I'll stop sharing this. I'll stop the recording. Still